welcome to lesson 6. This is about adding one-digit numbers and using the addition algorithm. Now, an algorithm is a way of doing a problem. So it's just the way that we're going to solve our addition problems. And it won't be too much different than what you've already learned. So we have some vocabulary words that I would like you to go ahead and copy down in your notes. Add-ins is our first one. Add-ins are numbers that are added together. So any number in an addition problem that is being added together, the two numbers, whether it's 3 numbers, whether it's 4 numbers, they are all add-ins, such as 6 plus 1. 6 and 1 are add-ins. The sum is an answer to an addition problem. So if I have 6 plus 1, which are add-ins, the sum would be 7. That is my answer in the addition problem. So we have add-ins, and then we have our sum. Now we have some rules and properties of addition. Our first one that we're going to look at is the commutative property of addition. That means numbers can be added in any order. This is basically common sense that you have already learned, that 6 plus 1 is the same thing as 1 plus 6. We're just giving it a name or a rule. That way it states, okay, this is why 6 plus 1 is the same thing as 1 plus 6, because I can add numbers in any order and you will still have the same answer. So we have some very basic review here, but hopefully we'll go over this pretty quickly. Example 1 says, what is the sum, meaning answer to an addition problem, of 7, 4, 3, and 6. I'd like you to go ahead and try that on your own first. Now, whenever I add, a way that I could do this is find numbers that equal to 10 first, because that makes it a lot easier. So I have 7 plus 4 plus 3 plus 6. Now, I don't have too much room. You're going to actually write it out in a better order, or at least give yourself more space whenever you're adding, but I need to make sure we can all see it. But whenever I look at these numbers in order and I'm going to add them, I know that 4 plus 6 is 10. That should be something that we should just have memorized. We should recognize the numbers or the pairs that equal 10. And I know that 7 plus 3 also equals 10. So when I'm adding 10 plus 10, I can do that simply in my head, and it equals 20. So the sum of 7, 4, 3, and 6 is 20. That way I didn't have to do 7 plus 4 is 11, 11 plus 3 is 14, and 14 plus 6. I'd have to do a little bit more thinking. That wouldn't be at least quick mental math for most of us. Some of you could probably look at that, still get it just as quick. But we like to learn the good shortcuts of finding, okay, those equal 10, these two equal 10, add them together. Example 2 is our next problem that we have. It says 4 one-digit whole numbers, it can be any 4 one-digit whole numbers, are added. Is the sum, meaning is the answer, more than or less than 40? Now, the only thing we actually need to know about this is that we have 4 one-digit whole numbers. Now, we talked about digits. Our digits are 0 through 9. So if I add any of those numbers together, I'll even take the largest one. If I did 9, I need 4 of them. 9 plus 9 plus 9 plus 9. That's the biggest sum that I'm going to get. Is it going to be less than or more than 40? Well, I automatically know it's going to be less than 40. So my answer would be less than, and I'll explain why. The reason why it's less than 40 is I know that 9 times 4 is 36. And in order for me to actually get a sum equal to 40, using 4 numbers, I would have to actually do 10 plus 10 plus 10 plus 10. But those are not one-digit whole numbers. 9 is smaller than 10. Therefore, my answer, my sum, is going to be less than 40. So we can go over and explain those, or we'll see a few more of those same types of problems where you'll just have to do a little bit of thinking of what you know about your one-digit whole numbers, adding them together. Is it going to be smaller than this answer or less than this answer? It can be any numbers. Our next property that we have in this lesson is identity property of addition, and this one's very simple. It says that anything plus 0 is going to equal that other number. So if I add 0 to anything, my sum will be that answer. So 2 plus 0, of course, equals 2, and 37 plus 0 equals 37. The way to remember the identity property of addition is that whenever you know your identity, such as if you know your identity in Christ, or you know your identity in who you are and you're strong in that and confident in that, then you're going to treat others with respect. You're going to honor them and you're going to prefer them above yourself. So whenever I have the identity property of addition, 0 says, hey, you know what, I'm pretty confident. I know I'm 0, but you know what, you can have the spotlight. The other number can be the answer. I don't need any attention. Same thing here. This 0 says, hey, guess what? I don't need any attention. I'm 0 and I'm okay with that. So guess what? The answer is 37. If I did the same thing, 42 plus 0, 0 is okay with who he is and he does not need to be the answer to everything. So that's how I like to remember the different identity properties. So we will come across another identity property later in a few lessons on multiplication, but for now it's identity property of addition. So 0 plus any other number equals that number. Now, our last example, this is example 3. Glad I caught that one. Example 3 says, Jamal had $462. Maria paid Jamal $58 rent when she landed on his property. So they're playing Monopoly, supposedly. How much money does he have? And I'd like you to actually do that problem by yourself, and we'll go over that answer in class. But this is a story problem, and you're going to have to add. Jamal had $462, but then Maria paid him $58, so he had $58 more dollars. So you're going to have to do $462 plus $58, and we'll go over that answer together in class. So thank you very much for paying attention.